As I was saying, we're going to start off this trigonometry unit by just learning or relearning the things we learned in grade 10, which were sine, cos, and tan. So what I want you to do first is, if you're using a calculator, make sure that your calculator is in degree mode. So at the top, you should have either the letter D or DEG to let you know that it's in degree mode. The other modes are radians and gradians, I think, and those are our calculations will be off if your calculator is in those modes. Okay, so here we have a right angle triangle. And the very first thing we do in grade 10 is we learn how to label this right angle triangle. So the little right angle sign tells you that it is 90 degrees. And then according to that right angle sign, the side that is completely opposite of it is known as your hypotenuse, which I'm just going to label as an H. It's always the longest side. And then in order for us to name the other two side lengths, we need an angle other than the 90-degree angle. So let's pretend like I'm talking about angle R. And by the way, we have very specific ways to label stuff. So here, this R is referred to as angle R. This S would be referred to as angle S, and this T would be referred to as angle T. And to label the side lengths, you just go right across and you label it with a little letter. So across from angle R is side length R, which is just going to be shown by a little letter. Across from angle T is side length T. And across from angle S, which is 90 degrees, is side length S. Okay, so we have angle R, angle S, and angle T. I'll just write them on the side, angle S, angle R, and angle T. And then each one of the angles has a corresponding side length, which we show with a little letter. No, you can just put the big letters for the angle, little letters for side length. Yes. Now, usually in a right angle triangle, you're going to have some sort of angle. And we use the Greek symbol theta, usually, like almost always in our questions anyways, to represent the angle. You can also use X, you can use literally anything, a Y, any letter, any variable, any symbol. And you don't even have to call it theta. We already know this angle has the name angle R, so you can refer to it as theta or angle R. Both of them are interchangeable. Okay. So that was basically just naming a triangle. And then in grade 10, we learned that every angle has a side length relationship associated with it. And you were asked to memorize these. They are sine of an angle is equal to the opposite side length divided by the hypotenuse. Cosine of an angle, the formula for that is the adjacent side length divided by the hypotenuse. And the tangent of an angle is equal to the opposite side length divided by the adjacent side length. Okay, so we know what the angles are, what the side lengths are. We know what theta means. So now let's say I draw a theta on angle R. The way that I'm going to measure, or the way I'm going to figure out what the hypotenuse, the opposite, and adjacent is, it's going to be in relation to this angle. The hypotenuse is always going to be the longest side length across from the right angle. That never changes. Right opposite of this theta is going to be your opposite side length. So I'm just going to put an O there to show you that it's opposite. And right beside this theta, now there are actually two side lengths that are beside the theta, but one of them is a hypotenuse. So that means the other one has to be the adjacent side length. So I always begin every question by figuring out what my opposite, adjacent, hypotenuse are. And now I'm going to use these formulas to write down the ratio. So see how for question 1, 3, and 5, it says sine R, cos R, and tan R. That's basically referring to the angle R, and it's asking you for the different ratios. Now, we actually don't have the hypotenuse. We could figure that out using the Pythagorean theorem, but I'm just going to tell you the answer so we don't have to do the work. I'm going to tell you that the side length for the hypotenuse is 39. All right, so when we're putting in our values, sine R is going to be opposite over hypotenuse. And remember, this is your R value right here. So opposite is 15, and your hypotenuse is 39. So the answer is just going to be 15 over 39. You could reduce this. You could divide both of them by 3, but I'm okay with us just leaving it unreduced because when you use your calculator, you get the same answer either way. What would cos R be? Adjacent over hypotenuse, yep. Perfect, 36 over 39. And what would tan R be? Yep. Perfect, 15 over 36 because it's opposite over adjacent. Now in the same triangle, we can look at the other angle that's not 90 degrees, and that other angle is known as angle T. So we're going to do the same thing, but this time we're going to figure out sine T, cos T, and tan T. Sine T would be, oh, and now that we're looking at another angle, we have to actually relabel our entire triangle. So if that's the angle we're looking at, T, the opposite side length is actually this. The adjacent side length is this, and the hypotenuse never changes. It's still going to be 39. So sine T is going to be 36 over 39. What's cos T going to be? You can just say it out loud. 15 over 39. And tan T would be opposite over adjacent, and it would be 36 over 15. Okay, now we haven't actually solved anything, but this is just asking us for the trig ratio, so we're going to go ahead and start solving it. How many of you are getting amazing grade 10 memories of this now? Does it sound familiar? Yeah, okay. Was it a fun experience? In grade 10, I mean? Like, oh, good, because you use it. Yeah, it's like patterns, or you just grab. All right, so I don't know if I want to do every single question. Maybe let's do. Okay, let's just start with question 7. We'll see how it goes. So for question 7, and we'll do a couple together. I'll give you a chance to do some of them on your own. For question 7, we have angle 38. You're going to notice I don't have A, B's, and C's or anything like that, and that's fine. We don't really need them. According to angle 38, this is going to be my opposite side length. This is going to be my adjacent side length, and this will always be the hypotenuse because it's across from the right angle side. Now, you're going to notice we don't have all the side lengths and we don't have all the angles, but that's okay. We don't actually need all of them. We only need really 2 pieces of information to figure out the third piece of information. The acronym that we use when we're dealing with sine, cos, and tan, and I'm going to write it just at the top over here because it's really useful. It's SOHCAHTOA. And if you just remember this, then you can kind of always figure out what the different formulas are. So now in this question, we're trying to figure out the adjacent side length A, and we've been given the hypotenuse. So if you look at SOHCAHTOA, which one of those are we going to use? We don't have any information about the opposite side length. So right away, I can eliminate 2 of them. I can eliminate sine and tan. Sarah, we would have to use cos. So the way we're going to do that is we're going to go cos theta is equal to adjacent over hypotenuse. I know what theta is because it's given to me. It's going to be cos 38 is equal to adjacent is x, and the hypotenuse is 21. Yep. Well, it's the only angle that's been given to us. That this 38 is the only angle that's given to us. So that's the one we have to use. Then you pick one. Yes. It can be anyone. Yeah. Marzu? Yes. You could have done the calculation to figure out this angle by going 90 minus 38 to get the other side length. And then you could have used the other angle. The only thing is you would then be labeling it differently. The x would be the opposite, and then 21 would be hypotenuse, and you'd use sine. But yes, you could do that as well. And then to solve for x, it's just going to be, we're going to move the 21 to the other side. So it's going to be 21 times cos 38. Go ahead, use your calculators and see what you get. And let's go ahead and round in. It says round answers to the nearest tenth, so just 1 decimal place. And then sometimes your question might have units, like side lengths can have centimeters and meters and stuff like that. If it doesn't, you could just leave it as is. Did you guys get 16.5? Okay. Oh, check your calculator. Maybe it's not in degree mode. Okay, so for question number 8, they've given us an angle 23 degrees. According to that angle, I'm going to label my triangle. So this is going to be the opposite side length. This will be the adjacent side length. And the hypotenuse is going to be over here. We have an angle, we have the opposite side length. We're trying to find the adjacent side length. So we're going to use sine, cos, or tan. Good. So we're going to go tan theta is equal to opposite over adjacent. And do you have to write the formula? You don't. I'm just doing it so we remember what side lengths are where. And then tan 23 is equal to 25 over x. And whenever the x is in the denominator, it does add like just a little bit greater level of difficulty, because what you have to do is you have to do 2 steps. You first have to move the x to the one side, and then you have to move the tan to the other side. And as you get good at them, you can actually do the steps at the same time, but I'll show you all the work. So it's going to be x times tan 23 is equal to 25. And then x is going to be equal to 25 over tan 23. So just make a note to yourself that when the x is in the denominator, you have to be a little bit careful because it does require that like additional step. We're going to go 25 divided by, and some of your calculators may require you to put brackets around the denominator. So 25 divided by bracket, tan 23 close bracket, and I get 58.9. So check to see if you get it. And to be honest, a lot of trig is knowing how to use your calculator properly, because you may get all the steps right and then mess up in the part where you're using your calculator and then get the answer wrong. Okay, we're definitely not going to do all these questions. It's overkill. Let's do one more where we're trying to find the side length. Let's go to question number 10. For 10, we have 31 degrees. So this is the opposite side length. This is the adjacent side length, and this is the hypotenuse. We have a question. For this one, we have 31 degrees. We have the opposite side length and the hypotenuse. So are we using sine, cos, or tan? Yep, we're going to use sine. So it's going to be sine of theta is going to be opposite over hypotenuse. I know what theta is. It's 31 degrees. The opposite side length is 19, and the hypotenuse is x. So again, we have the x at the bottom. Now I'm just going to mentally say, okay, x goes besides the sine 31, and then the sine 31 comes to the bottom. So it's going to be x is equal to 19 over sine 31. And then for that, I get 36.9 centimeters, units, whatever it is. Did you guys get that? Are we all okay with this? All right. Now for these 3 questions, you're going to notice that we have been trying to find the side length. What do we do when we have the side lengths and the angle is what we're trying to find? So let's try question 11, which has a scenario like this. So for question 11, if I label this, they've given us x degrees. So we're clearly trying to figure out what the degrees are. This is the opposite side length. This is the hypotenuse. And this is the adjacent side length. So I'm still going to label my triangle in the way that we've learned. And I'm going to look at the numbers that are given to us. The opposite, the side length, and the hypotenuse have been given to us. So what do we have to use for this question? We have to use sine. So I'm going to start with sine theta is equal to opposite over hypotenuse. I don't know what theta is. I'm just going to call it sine x because that's the variable they've used. And then opposite is 15 and your hypotenuse is 23. Okay, now here is a very important piece of information. Whenever you are trying to find an angle, you have to use a very special button in your calculator, and it's called the sine, cos, or tan inverse button. So I'll give you guys a second to go ahead and find that button. For my calculator, and many of you, you might have to put the little second function and then press sine, cos, or tan. But when you're done pressing your buttons, you should see sine -1 on your calculator screen. So now what we're going to do is we are going to press that sine inverse button, and then we're going to put brackets and write 15 divided by 23. You do not have to show me the step, but I'm just going to write down what you're going to be pressing on your calculator. It's going to be sine inverse, and then you're going to go bracket 15 divided by 23. And the step I've written down right now is not necessary. You don't have to write that down on your sheet. When you do that, you should get an angle measurement, and we're going to keep it to 1 decimal place. So I get 40.7 degrees. Did you guys get that as well? Yes, Marzouk? Just do 12. All right, so for question 12, I have, again, x degrees. I'm going to label this opposite, and this is adjacent, and this is the hypotenuse. If I have the opposite and the adjacent, what am I going to use? Sine, cos, or tan? Tan is correct. Tan theta is equal to opposite over adjacent. I'm going to fill in my information. So theta is just your x. Opposite is 37 and adjacent is 8. And by the way, hopefully you guys can see that once you label your triangle, it becomes so easy because you're not thinking, you're just literally grabbing the number from your diagram. And then what you're going to be doing is now you're going to be using the tan inverse button. So it will be tan -1, and then in brackets, you're going to put 37 over 8. So go ahead and try that. Yeah.
You know, the actual opposite is kind of the hypotenuse. So, like, how would you know if the side of 37 is the opposite or the side of 8?
You're right. You're right, because okay, so I can see that. The thing is, across from the right angle, we always label it hypotenuse, even though technically it's like an adjacent side length because it's adjacent to this one, but the hypotenuse supersedes everything. So you will always label that hypotenuse. And that's whatever side length is across from the right angle. Then the other two is what you're going to be picking as opposite and adjacent. Yeah. Okay, so I ended up getting 77.8 degrees. You guys get that as well? Okay, awesome. I feel like we're kind of comfortable with this, so let's just keep going. I want to go over maybe just a few word problems from this, and then we're basically done our first mini lesson. Okay, now the reason I want to go over this is because it has the words angle of elevation and depression. And I want to just talk to you about that and tell you what that is. Now, often in these kind of diagrams, you're always going to have some sort of point of view. So let's say I have a person standing around, and here is his point of view right over here. Okay, so I always start by someone's point of view. It might just be like a building or an airplane, but that's always the horizontal. Now let's imagine that he is looking up at a couple of birds. And when you're looking up from a certain point of view, like this angle over here is known as the angle of elevation. So it's always measured from a horizontal, and then you're looking up, and that makes sense, right? Elevate means to look up or go up. So it's the angle of elevation. Now, what if he's not looking at birds, but he's looking at the bottom at an ant or pebbles or something? Now, when he's looking down, this part right here is called your angle of depression. Are you guys laughing at my ants? Yeah, they sure are. So that's called your angle of depression. So it's really important to just recognize how we're going to be drawing the diagrams. They're always measured to the horizontal. Up is elevation, down is depression. Okay, let's try question 15, and maybe we'll do question 18. So question 15. It says draw a picture for each problem, then solve for the missing part. A picture is like so crucial for these types of questions. The angle of elevation from a soccer ball on the ground So the top of the goal is 34 degrees. So picture it, soccer ball on the ground, goal post is up here. That angle of elevation is 34 degrees. If the goal is, and I apologize for the use of feet, this is clearly an American sheet, and so we don't use feet as often. You're gonna find a lot of feet in here. So it's 8 feet tall. What is the distance from the ball to the goalpost? Your diagrams may all look different, and that's totally fine. You can draw it however you want. I'm gonna assume my soccer ball is here and my goalpost is maybe around there. Maybe instead of that, I should just use this. That's a better idea. Okay. Of course, I'm going to be struggling with this. Okay, that's not bad. And then I will just draw this line over here. Okay, and so I'm just going to label an S for my soccer ball, so I know that this is where the soccer ball is. And then the G for my goalpost. It doesn't matter what letters you use, or if you use any letters at all, doesn't matter. Now, the question has told us that the angle of elevation is 34 degrees, so that has to go from the ground up. That's going to be 34 degrees. And they've told us that the goalpost is 8 feet tall, so that's going to be right over here. And they want to know what is the distance from the ball to the goal, so you're basically trying to figure this out. And honestly, the hardest part about these questions is figuring out the diagram, because we've just done all the calculations, so we're pretty good at that. I'm also going to label my right angle, because these are all right angle triangles, so just make sure you have that there. Sarah? That's a diagram. Yeah, it doesn't have to be like fancy at all. It's just a triangle. So go ahead and solve this, and I will do the same up here. Hey. So the question is saying, what is the distance from the ball to the goalpost? I guess that's how you interpret the question. For me, that would mean at a horizontal, because they didn't say to the top of the goal. Yeah, I guess to be more clear, I'm assuming this question is saying, what is the distance from the ball to the bottom of the goalpost? Yeah, no, but you're right, actually. It's a little ambiguous. So they should have said either the bottom of the goalpost or the top of the goalpost. Let's assume it says the bottom of the goalpost. And I always make sure when I'm writing these questions, I triple check them, and they make a lot of sense. So we'll be really clear in our class. So tan 34 is equal to 8 over x, and x is just going to be equal to 8 over tan 34. I'm just going to make a general rule that we will always do stuff to one decimal place to avoid any confusion. And I end up getting 11.9 feet. This is a word problem. You should probably write a therefore statement on a test, and then here will be fine. Did you guys get 11.9 feet? No, just at the end. Yeah, just at the end. And technically we need a let statement. You know what? We'll worry about that later. All right. Oh, Sarah, look, you're in a question, but we already did an angle of elevation, so I want to do an angle of depression. Let's go all the way to question 18, and let's try that. A spectator in the stands, so high above, spots the team mascot on the field at an angle of depression of 46 degrees. So visualize this. You are a spectator in the fan, you look down onto the field and you find your mascot. If the spectator is sitting 35 feet above the ground, what is the horizontal distance between the spectator and the mascot? Do you see this question is a lot more specific, and I like that because they're talking about the horizontal distance. So let's draw information here. Now you always have to be a little bit mindful of angle of depression, because look, I'm going to label this, my spectator is over here at the top, and then the team mascot is down here at the bottom. And if you drew your triangle the other way, that's fine. It's just you're labeling it a little bit different. Now, if he is looking down, remember, you always want to label your angle of depression and elevation from the horizontal. So I'm actually going to have to draw in a little bit of a fake horizontal line to remind me that my horizontal line is whatever the spectator is looking at. So the spectator is standing in the stands, so the line is where his vision is. And then the angle of depression is actually going to be 46 degrees from there. So this right here is going to be 46 degrees. You couldn't have, because that's not the angle of depression. The angle of depression always has to be measured from a horizontal line. And so if you wrote the 46 here, there's no horizontal line, right? So that's why for an angle of depression, you always have to remember to draw that horizontal and then draw it in. Let's fill in the other pieces of information. So the spectator is 35 feet above the ground, which is going to be right up there. What is the horizontal distance? So we're trying to figure the x out over here. Now you can do one of two things. You can think back to grade 9 and remember your angle rules. And there is a rule that says if you have an angle here and you have two parallel lines, that is going to be the same angle over here. If you did not remember that, that's totally fine, because the other rule we know is this is 90 degrees. So if we have 46, we can just go 90 minus 46 to give us 44. And this angle measurement right here has to be 44 degrees, because both of those have to add up to give you 90. So either one of those ways is fine. And by the way, if you calculate that to be 44, then right away you know that according to the rules of an interior of a triangle, this has to be 46. Okay, so we have a lot of options for this question. We can use a bunch of different things. So this was 44 and that's 46. It doesn't matter which one you choose to use. Pick an angle, label your diagram, and figure out what it would be. And I'll do the measurement up here as well. So I'm going to use tan 46 probably. So tan theta is equal to, and we all have to be using tan because the hypotenuse is not given to us at all. You could use either. Doesn't matter. If we want, we can use the 44. So tan 44. And then actually tan 44 would be easier because then the x is at the top. So it's going to be tan 44 is equal to x over 35. And then x would just be 35 times tan 44. And so I get x to be 33.8 feet. That'd be our final answer. Let me tell you what you're going to be doing for homework, and I'll actually pause so you guys can take. It's actually the next two sheets, but I'm going to say pick and choose. I know there are a lot of questions and it's repetitive. I'm going to just pick and choose whatever questions you feel you want to do. So this is page 1, and I've actually posted the answers for this on Brightspace because I know that I didn't include it here. So page 1 is just getting you to use SOHCAHTOA. And then page 2 is just word problems. If you feel like you're not so confident with word problems, then maybe do all 5 of these for extra practice.